So now that we have a good understanding of weather and just how it affects our airplane, the next thing to learn would be how to read and interpret the weather charts and materials that we're given as pilots. You see, we're actually given a lot of different weather supplements to help make us safer, and it's ultimately our responsibility to be aware of those supplements. So the first chart to look at is called a winds and temperature aloft forecast. You see, the winds and temperature aloft forecast you can find on multiple different supplements, but one example would be aviationweather.gov. And on aviationweather.gov, finally when you navigate to this section, you would get this weird mumbo-jumbo chart full of letters and numbers. It almost looks like computer programming. But one thing I can promise you for sure is it is nowhere near as difficult to figure out this than it is to program a computer. So when we look at this, let's break it down. We have obviously the altitudes up here, as it says in feet, 3,000, 6,000, 9,000, 12,000, 18,000, 24,000, and so on and so forth. I think you get the picture that it's not every 1,000 feet. It appears to be in increments. Now under the feet, we have a bunch of different letters, and these are the airport unique identification codes. If you recall in a previous video, every airport has a 3-letter unique identification code to identify it. So ATL is Atlanta, TLH is Tallahassee, PIE, or PI for short, is St. Petersburg, and so on and so forth. But I think the hardest part to interpret on this chart would be the meat and potatoes, the numbers all in the center of this that actually look like coding. But let's break it down individually. You want to break it down into 3 different parts. You see, there's technically 6 digits per every section. So if you break it into 2 parts, you have 3 sections. So let's start with Jacksonville at 9,000 feet. It says 2217 plus 12. Well, let's break it into increments of 2. So again, you have 2217 and plus 12. So you have wind direction, wind speed, and then the temperature at that altitude, or the temperature aloft. So when we look at Jacksonville at 9,000 feet, we have 2217 plus 12. Okay, but is it 022? What's the direction? Well, you see, they just omit the 0, the same way they omit the 0 on runway designation numbers. So you just add a 0 for everything. So in this case, it's 220 degrees at 17 knots, and the temperature is plus 12 degrees. Simple enough. But let's make it a bit more complicated. Let's stay with Jacksonville, and let's go up to 30,000 feet. We have 26, 76, 35. So again, we've broken it down into increments of 2. We have 26, 76, 35. Okay, so we have 26, add the 0, 260 degrees at 76 knots. But hold on, the temperature is 35, but is it positive or is it negative? You see, there's one thing we got to take notice to, and it says up here that temperatures are negative above 24,000 feet. And we're at 30,000 feet, so they don't put a plus or a minus sign because it's always going to be negative. So you would say that the temperature is minus 35. So again, 260 at 76 knots, temperature minus 35 degrees. There is one more thing that could stump you, and when you see a 7 where the wind direction should be. Now you and I know that there are not 700 degrees in a compass, so how exactly do you have a wind direction of 740 degrees? Well, actually the 7,4 you need to subtract from 50. So the rule of thumb is anytime you see that, you subtract 50 from that category. So 74 minus 50 is 24. And then you add the 0. So you and I know that this would be 240 degrees because you subtracted 74 from 50 and got 240 because you add the 0 at the end. But why not just put 24? Why put 74? Well, the 7 actually lets us know something interesting about the speed. The reason that we have to do that math is to let us know that the wind speed we need to add a 0 onto. So we know that the wind direction is 240, and it says that it's 12 knots, but we add the 0, so it's 120, 120 knots. And then again, it's above 24,000 feet. So you and I both know that the temperature is minus 54 degrees. Now, what if you're at an altitude cruising that's between, let's say, 6,000 and 9,000? Let's say you're between 8,000. Well, you would decode both of the readings at 6,000 and 9,000 feet, and then you would just get a median. You would get an average, and that's called interpolating. You see, in aviation, you have to be pretty precise, but not everything you do is going to be to the T. So when you're at an altitude between 6,000 and 9,000, you interpolate the average between those numbers for direction, speed, and temperature.